2, which is all about the mean value theorem. Now, the mean value theorem is the most important result in differential calculus in that it allows you to say lots of things about the function from knowing about its derivative. So first, let's state the mean value theorem. It says, let f be a function that is continuous on a closed interval ab, that is differentiable on the open interval ab. Then there's a number c in between a and b, such that f prime of c is equal to f of b minus f of a over b minus a. Now, that is kind of hard to understand what it's really saying. The theorem is saying becomes a lot clearer. This f of b minus f of a over b minus a can be considered a difference in y values over a difference in x values. In other words, this is the slope of the line segment from the point a comma f of a to the point b comma f of b. We call that a secant line. And f prime of c is the slope of the tangent line. So it's saying that for any points, if you make a secant line between those 2 points, there's going to be a point in between those 2 points where the tangent line at that point is going to have the same slope as the secant line. And then if we scroll down a little bit, we can see, well, I can't, there we go. We can see a couple of illustrations of this. So of course they just drew the graph in, but here this blue line segment is the secant line from a f of a to b f of b, and that they were able to find a point c such as the slope of the tangent line was exactly that slope of the secant line. And over here, it's the same game. In blue, we've got the slope of the secant line from A to B. And here, they were able to find 2 points. The mean value theorem says there'll be at least 1 point where the slope of the tangent line is the same. In this particular example, they found 2. So to illustrate just how powerful the mean value theorem is, a nice example is this theorem, which says that if f prime of x is 0 for all x in an interval, then f has to be constant. So this might not be that surprising, but without the mean value theorem, you couldn't prove it. So it's a nice way of telling when a function is constant is if you can check its derivative and notice that it's 0. And how does the proof go? You just take any two numbers in the interval, and then you apply the mean value theorem to those 2 x values. And the mean value theorem is going to give you that that the f of x2 minus f of x1 is going to equal f prime of c times x2 minus x1. And now, since the derivative is equal to 0 everywhere in between x1 and x2, this right-hand side is just 0, so f of x2 has to equal f of x1, so it's a constant function. And finally, I thought it would be fun to make a Desmos app which allows you to check how the mean value theorem works for any function you like. So right now, I have the function f of x equals x times sine x plus x. And then I can take any 2 points and drag them around, or at least I'm supposed to be able to drag them around, but things are being a bit slow. And then it's automatically making the secant line between those 2 points. Though it's being very hard to move. There we go. So right now we've got the secant line from over here to over here. And then you can move the point around which you're taking the tangent line, and you can try and get it to be parallel to that slope of the tangent line. The mean value theorem says that this will be possible. You can even scroll down a little bit and check your answers at the bottom. So right now at the bottom we've got f prime of c is stay still, will you? F prime of c is 0.36, whereas the slope of the secant line is 0.618. Okay, so can we get better? I'll try moving that over a little bit. There, we got a little bit better and got them much closer. And you can also notice that we could also find another point up here that would do the same thing. So can we find this point up here that'll make the slope of the secant lines be really close? I'm not having much luck getting the app to work. It's just being really slow. But as you can see, we found a point really close in there. And right now we can kind of check our answer a little bit. If we come over here to the left, well, I kind of moved it a little bit. But we got the tangent line to have slope 0.45, whereas the secant line has slope 618. All right, I could have done a little bit better, but you get the idea. You can play around with it, and it'll work much better on your computers. All right, that's all. See you next time.